Well, hello and welcome, Math 1. Mr. Robinson here with a brand new exciting two-part video series on triangle congruence. Side, 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 angle, side is part 1. Angle, side, angle, 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 side is part 2. We're actually going to skip HL, mostly because I'm not getting any good activities on it that I can find for you to practice. Not on Khan Academy, not on IXL. The practice problems I do with you today here are going to be from IXL, literally ripped from there, so it can help you best. You're going to be learning to do what are called two-column proofs. You're not going to build them in full. It's mostly going to be complete for you. I'll tell you what it is. You'll see what it looks like. We'll do practice problems with it. Let's go ahead and get started. Before we do the actual problems themselves, I want to make sure you know not only these terms here. I just want to tell you what a two-column proof is. You're going to be doing a lot more of this when you jump into Math 2 at some point. You have to prove, basically, that two triangles are congruent. And we're going to be doing that using any of these conjectures right here. Side, 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 angle, 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 side. HLI asterisk, because once again, we're not going to be doing it. But a two-column proof is this. A column involving statements and reasons. Now, the statements will be pre-built for you on IXL in this case here. You're just going to have to justify some of the reasons. Mostly, you're going to be doing the congruent statement reason. Every so often, they'll ask you to do some other things. That's why I have this stuff for you, so you know what the heck it all means. It's a way of making claim to show that certain parts of the triangle are congruent. And once you've built up a case and evidence to say, now I can use side, 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 whatever, you're going to make that final concluding statement. So there might be a first statement that says blah, 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 and there's a reason behind it. We can justify it. The first ones you generally see on the proofs will be called given. It'll be a given reason. Basically, they told it to us. Okay, so if we have that information told to us, we're going to have to draw conclusions for the other statements that we make. And again, they're going to make the statements for you. Just draw a conclusion for it. And again, it's going to be based on this stuff. But finally, eventually, you have enough parts to be able to say that one triangle, say triangle ABC, is congruent to triangle DEF. And in this final statement, it always is one of these five. It always is one of these five. It's never anything else. If you see CPCTC, if you see definition of congruence, they're not it. It's only among these five. These are the only five that can ever actually happen as the triangle congruence statement. So maybe this one could be angle, side, angle. Okay. They might say property of congruence and other things with it, but that's the last statement that you make. Okay. So again, building a case for the final statement. It's kind of like convicting somebody of murder or something where, you build the case and you say, therefore, because of this, he's guilty. Right? So you state that. So let's go ahead and look at these things right here so we understand where all these other reasons are. Some of them you might know, but I just want to make sure you understand how it's kind of broken down. All right, first word right here is midpoint. A midpoint is a way of dividing a segment into two congruent parts. Let's say I have segment AC, and if I stated that B was the midpoint of segment AC, that means that segment AB is congruent to segment AC. So you're going to see things such as a statement, first, a given statement that B is the midpoint of AC, and then you might see a statement that segment AB is congruent to segment AC or BC, because reason, that's the definition of a midpoint. So you can see that, that's how you justify it, right? Because it's a midpoint, they're congruent. Things like that. I want to work fast here, so I'm just rushing through, sorry. Vertical angles. Vertical angles, we've seen a lot of this before. It's where you have, say, two lines right here, and then it kind of makes like the hourglass-looking figure. The opposite angles are congruent to each other. Say these two are congruent to each other, and then these two here are congruent to each other. You might see me doing congruent arc marks like these, like double arc marks like this. Every so often, just by nature of habit, you might see me instead always do single arc marks, but then I'll do certain tick marks here. Like one tick mark for those, two tick marks for these, something like that. I don't know which one I like more. It just depends on how my drawings look those days. But all vertical angle pairs are congruent to each other. Alternate interior angles occur when you have parallel lines, and I know parallelism comes after this, but I want to say more on that later. Where you have parallel lines such as like these ones, if you know they're parallel, and there's a transversal, you have alternate interior angles, say right here. When lines are parallel, the angles are congruent. Okay, when those lines are parallel, the angles are congruent. And same with these two right here. These are also alternate interior angle pairs right here. These would also be congruent. It's a lot more obvious right here. It's going to be less obvious in the pictures that you see, because you're going to end up seeing things like parallelograms, like such as this one right here. Very rough drawing, sorry. If I have a parallelogram and a diagonal that cuts through the parallelogram, see, a parallelogram has parallel sides, opposite sides right here. So these two sides are cut by a transversal right there. That makes alternate interior angles. Again, I know a rough drawing, and I'm sorry about that. I just want to rush through. These are congruent for that same reason. So I know I have some videos on that break that down a lot more, so I'm going to have to find something like that to really help you with that more, but it's the understanding. Maybe I'll do it for a specific problem here and slow it down, but that's where you'll see alternate interior angles with parallel lines. Remember that. All right, what are parallel lines? They're lines that never intersect because they're on the same plane and they run in the same direction, but they're unique lines. So instead of being right on top of one another, they're, separate. They never intersect, and if they went on forever or not. So two parallel lines like that. Now, how do you mark parallel lines? If this was line AB and this is line CD, first of all, you might see a statement that says segment AB is parallel to segment CD like that. Okay, that's the parallel statement. It's kind of like two L's right there. And it makes sense. These don't intersect. Two L's in that totally makes sense. When you see me draw things with parallel lines, you're going to see me make these little arrow symbols like this. This doesn't mean congruent. This means parallel. Okay, so that's what that thing means there. Next one, perpendicularity. If parallelism is all about two lines that never intersect, perpendicularity is about two lines that intersect at 90 degrees. So if I have these two lines right here that intersect at 90, you'll either see me draw a right angle symbol or it'll be drawn for you. But a perpendicularity statement, if this is line AB and this is line CD, you're going to see it say segment AB is perpendicular, to segment CD, and this is the perpendicular symbol right here. Okay, so same kind of thing. It makes sense because it looks like it's making a right angle right there. The other thing I want to state here is that, every right angle is congruent to each other. So the fact that I made one right angle symbol here doesn't mean these should all get right angle symbols, but you kind of don't need to draw them. Once one of them's 90 degrees, all the others by nature have to be because of, supplementary angles. 90 plus 90 is 180, things like that. They're adjacent. They all form linear pairs. So they're all 90 degrees. It only takes one to do it. But we get to say that, if this is point E, angle AEC is parallel to angle CEB because all right angles are congruent. Okay? All right angles are congruent. And that's another reason we're going to be using if we have perpendicular lines. All right, two more. Angle bisector. An angle bisector, if I have an angle here, angle ABC, a bisector is something that goes through the middle of it, like this ray right here, ray BD, and it divides the angle into two congruent parts. It's kind of like a midpoint for angles instead, not really, but but that's what it's called. It's called an angle bisector. There are things called segment bisectors, but it's not just a point, it's a whole line. An angle bisector here divides these into two congruent parts. Angle ABD is congruent to angle DBC. That's what the BD did. It said BD bisects the angle ABC, and it says that. So that's an angle bisector, divides into two congruent parts, and again, for a reason to know they're congruent, definition of angle bisector. And finally, reflexive property. This one gets kind of weird, but I'll try and go super fast with it right here. If I have two triangles here, and they kind of overlap, not fully, but they do just enough. They're not fully congruent here, but what they do is they share this side. See this side right here, AC? AC exists in both triangles. If I split them apart, you'd see a segment AC in both of them. But the fact that it now exists as both of them shared together means I can make a statement that segment AC is congruent to itself. Well, no, duh. AB is congruent to itself as well. Yeah, but AB doesn't exist in both triangles. AC does. See, the whole point of these statements here is you got to state that parts are congruent to each other. So you can call the reflexive property a congruence and say that segment AC in this triangle is congruent to segment AC in that triangle by the reflexive property. It's a shared side in both triangles. Likewise, you can do it with not only shared sides, but also shared angles. Let's say I have this triangle right here, and then I have this triangle right here, and now they share this angle up here, A. I'm not going to name all the rest, but this angle is used in this triangle here in blue, and it's also used in this triangle here in green. Angle A is congruent to itself by, once again, the reflexive property. A shared side or angle in two objects is automatically congruent to itself, again, by that property. All right, so I spent enough time on the screen here. I'm going to go and move on. So this video is going to be a little bit longer because the other one, I'm just going to point to this and say, if you want to see the stuff, go to the first video for it. So let's go ahead and move on. Let's look at some problems here. Here's an example of two-column proof, and here's a given statement of stuff, and they're going to break that down for you. First statement, segment RS is parallel to segment TU. They show that right here. That means it's given. Now, they didn't draw it. So I'm going to go ahead and draw that for you right now. Segment RS is parallel to segment TU. Like I said, I'm going to be doing arrows to indicate that. Okay. Now, that doesn't say that they're congruent. However, they do give us that segment TU is congruent to segment RS. TU is congruent to RS. You can see those markings right there. They are congruent. Now, they're going to build the rest already for you. We just need to draw the things in so we make sure that we use the right thing. Keep in mind, this is the side, 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 or side, angle, side video. You're not going to see angle, side, angle, or angle, angle, side in this video. All right, angle RTU is congruent. This is angle RTU is congruent to angle SRT right here. This is the alternate interior angles theorem. This, again, goes back to the idea that you have, and I said I'd do this, and it's the first problem I can actually do it. Two parallel lines right here are cut by a transversal right here. So can you see it a little better? Tilt your head sideways. Two parallel lines cut by a transversal. See those alternate interior angles? Not as obvious when that's not drawn, but it's there. Those are congruent. Anyway, that's important because you're going to have to be doing some of these on your own as well. Not the statements, but the reasons down the line. Okay. And finally, segment RT is congruent to itself. See this RT right here? It's a shared side in both triangles. That's the reflexive property of congruence. You can already see these things building on each other. I don't really need the parallel lines anymore. That was used for the congruent angles bit. So check this out. Triangle RTU is congruent to triangle TRS. Hopefully you understand why the order matters there. By what thing? It looks like it goes side, angle, side in this triangle with side, angle, side in this triangle. That's the side, angle, side guy right there. If you can already tell that you know you're going to see side, 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 or side, angle, side, you can use it and move on. I understand that, but again, eventually you'll be building it, so it's good to look at these, mark them up, and know what you're doing. All right, next problem here. Once again, we're just going to use one last bit here. We're given two parts right here. That segment UV is congruent to segment TV, so these two sides are congruent. And then these two sides, RV is congruent to SV, and then angle RVU is congruent to angle SVT. Now, they didn't label it. They didn't give it to us, but these are vertical angles. Angle RVU right here is congruent to angle SVT right here. Those are vertical angles, right? We have another side angle side case. Side angle side with side angle side, angle STV or triangle STV is congruent to triangle RUV. You might be in disagreement with how they ordered their letters to start with. You might want to say SVT. It's up to you. That's really up to you. But however you start one, the other has to fall in correspondence based on the ordering of the first one. Anyway, here's another side angle side right here. And I'll go ahead and move on with that one. Hold tight for 1 second. I got unaligned on my own video. There we go. Okay. Next one here. Nothing's marked, so we're going to have to build some stuff up. K is the midpoint of GI and HJ. Okay, this is interesting. This point right here, K, is the midpoint of this segment and of this segment right here. So you're going to see some statements here that are going to help you out with that. So K is the midpoint of GI and HJ, given. Given statements, let's start building a triangle congruence proof. GK is congruent to IK. How do we know that this is congruent to that right here? Because K is the midpoint. Definition of midpoint makes these two guys congruent here. Same with these two, HK and JK. These two are congruent right here, definition of midpoint. Separate bits of congruence, but they are. We have side and side. With side and side, we need either a third side or an angle. Now, if you were to build this yourself, I can't do anything to state that these two sides are congruent here. I don't have enough information. However, I can state that the angle in between these sides are congruent. Angle GKJ is congruent to angle HKI because these are vertical angles like we just saw last time. Okay, now we have another side angle side. Looks like we're getting a lot of side angle sides right here. And keep in mind, side angle side means that the angle has to be in between the sides. You can't have an angle, if these were alternate interior angles right here, this is not side angle side. The angle is not in between the two sides that are congruent. This is angle side side. That's not allowed. And you can see why. But that's not allowed right there. Side angle side is the one that you use here. All right, next problem as we keep moving on. T is the midpoint of segment RS. That is given. So we can already tell that we're going to be doing this two-column proof will help you right here. The midpoint helps you make this statement right here. Because T is the midpoint of RS, segment RT is going to be congruent to segment ST right here. That's by definition midpoint. So you can tell that statement 1 helps us build statement 4. It's kind of far down, but that's okay. Segment QT is perpendicular. Remember, this means perpendicular right here to segment RS. So QT is perpendicular to RS, and they already drew the right angle symbol for us. That's nice. Now that's given, and because of that, that makes these two angles right here congruent. This angle with this angle. Remember, they're both right angles. They're both 90 degrees. 90-degree angles, equal measures, means congruent angles. All right angles are congruent. So therefore, boom, two congruent angles there. And then the segment QT is a shared side in both triangles, so it's going to be congruent to itself. This is once again one of those reflexive properties. It's a shared side in both. We have, once again, a side angle side. Triangle QST is congruent to triangle QRT. Again, you're not going to build statements in these videos, which is nice, but I think more reasons are going to come in just a moment. But building that up is a nice go-to and start. Okay, so now you can tell that you're going to have to build one for yourself here, see what it's going to be. We are given segment QR is congruent to segment PS. So QR with PS right here. QR and PS are congruent. PQ is congruent to RS right here. Those are givens. They're already stated, but we got to mark it. And I don't know anything about parallel lines, but I know that this is a shared side once again in both triangles. PR is congruent to itself. That's the reflexive property again. That's the reflexive property of congruence. I'm just going to put reflexive property there. This is going to be your first side, side, side one. These two triangles are congruent by the side, side, side theorem. Again, this is the only thing you can write in here. Either side, 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 angle, side, angle, side, angle, 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 side. You can't. There's going to be something called CPCTC that down the line you're going to learn. It's not here. That's not what it means. It's actually the statement that's used after this if you're going to prove that other parts are congruent. All right, but I'll move on with the video because I've already spent a lot of time in the beginning. All right, parallel. WX is parallel to UV. So WX is right here. I got to draw the parallel symbols with UV. Looks like we're going to work with some alternate interior angles in a parallelogram. Be ready for that. That's given. Also, segment UV is marked and therefore given. It's a congruent segment WX. They're congruent, so two sides congruent. Let's look down here and mark this first. Segment UW is congruent to itself by the reflexive property, once again a shared side. And we have two parallel lines right here cut by a transversal. That means that you have alternate interior angles. Remember where the parallel lines are. I'm going to do this rough. Parallel lines are here. Here's your transversal. That makes alternate interior angles here and here. These two angles are congruent to each other. Now they give you that statement, okay? But it's angle UWX is congruent to angle VUW because those are alternate interior angles, okay? Again, parallel lines. It's with parallel lines. They're congruent. And all the rest is built for you. That's great. So side angle side. You can see right there. Side angle side. All good. All right, moving on over. Line WZ bisects angle XWY. Here's angle XWY right here. Here's the bisector. A bisector, again, divides the angle into two congruent parts, so I'll make sure to label that once it comes down to see that statement. Bisector given. It's also marked up and given that these two segments are congruent to each other. Okay, we're getting to that statement now. Angle XWZ is congruent to angle YWZ because their angle definition of angle bisector. Okay, that's definition of angle bisector. That's what it did. Okay. WZ is congruent to itself by the reflexive property one more time, and you have a side angle side case right here. Side angle side with side angle side means these two triangles are for sure congruent in all parts. Again, you only need so very little to prove it. You don't need to prove that this angle is congruent to that one, this angle is congruent to that one, this side's congruent to that one. There's only so very little that you need in these four statements to tell you that. Okay. This is the last one in this video here because I'm getting near the 20-minute mark, and I promise the other one's going to be faster. J is the midpoint of HI. That's all given. All right, so midpoint here. Let's go and start marking stuff up now that we know that, and then we'll get to the statements after. If this is the midpoint of this segment, that means these two parts are congruent here. If this is perpendicular by this statement and by this marking, that means this is also a right angle here, and that means these two right angles are congruent to each other, just by nature. And then this segment is also congruent to itself. You can see how it's possible to build these on your own once you have the given stuff. You can start to figure out, once again, it looks like a side angle side. So let's see if we can fill it out all with that. All right angles are congruent. That makes this angle congruent to this angle right here. All right, we got that set up for us. HJ congruent to IJ, these two parts we marked. How come? The midpoint. Definition of midpoint. MDPT is midpoint for me. GJ is congruent to itself by the reflexive property. I'm at the 20-minute mark now, sorry. And finally, looks like we have another side angle side case here. Now, one thing I want to state here is I said that HL exists in right triangles only. HL stands for hypotenuse leg. This is not HL just because it's a right triangle. HL means you know one of the sides of the legs are congruent and you know that the hypotenuses are congruent, understanding that it's a right triangle. This is the exception to the angle side rule. We're not doing HL, but don't say just because you have a right triangle it means it's HL. No, no, no. If you have side angle side, you work it out. All right, so that's the last one here. That ought to do it for this one, guys. This was part 1, and like I said, I promised it would be longer because the first half of this video was set on making sure you knew those terms. We're going to use those terms again. I'll revisit that page, but I'm going to go straight to the problems for angle side angle and angle angle side. Okay, take care.